Hello everyone, my name is Ratul and today I'll be walking you through my solution for the BlackRock Autosave Engine challenge. The goal of this project was to build a highly optimized scalable micro investment system, a system that can take everyday transactions, calculate the spare change, validate financial limits, apply complex temporal rules and project future wealth, and also consider tax. To achieve this, I used a two-part containerized microservice using Python fast API service, and I have made a CPP engine to calculate the returns, NPS and index returns. So the architecture diagram and all the details of the project are comprehensively given in the readme.md file along with the setup commands. Even if using local setup, the commands are given as along with the Docker configurations. Coming back to the project, the inner engine is basically the C++ engine, where I have used a sweep line algorithm basically to have the time complexity of n log n rather than a time complexity of n square. By if I used a time complexity of n square, I had to reiterate through all the q, p and k arrays. So I used a sweep line algorithm which solves the problem in n log n time. And I have made a custom index.html file which allows the tester to check all API endpoints. Yeah, so basically this is it. Here in this drop down I have every API that was needed. So if I do first of all, let's go to parse. This was basically the transaction builder. If I have made a test case over here, which is this. Copy this, paste this and do execute API payload. Yeah, here I have my Docker running over here with the image I have pulled. Yeah, I have added the ID and status tags because in a real life scenario each transaction is associated with an ID. I have just used a random ID generator code. Coming back to the validator, maybe I keep the same transactions and maybe I give annual wage this. So if I do execute API payload, yeah, it gives valid and invalid transactions. And then if I go to filter, which was basically the transaction filter along the, I have this filter, wage is 50,000. If I just copy all this, this is basically the queue periods. And this transactions, let's do this. Yeah, and this format this JSON and keep this the same. And if I do execute payload, yeah, as you can see, this also gives valid transactions and invalid transactions. This is not showing invalid transactions because in the previous API I have cut out all the invalid transactions, if any. Next is the NPS return calculator. If I do 29 inflation, this Q periods, if I have this over here, multiple Q periods, if I take multiple P periods, and the K periods. What is the transactions? Yeah, so if I now execute the payload, as you can see, savings by dates comes over here. Same goes for the index. If I do this, it changes. Profits, it which has changed. And finally the performance matrix one, if I just, there is no input needed whatsoever, so if I do just execute pi payload, it sees the up time in seconds, it gives the engine calls, which is 1. It uses very less memory, as you can see, and peak is 3. Active threads is 1. I have given the algorithmic efficiency of it here 1 million transaction, because the constraints was given 10 to the power 6. The time complexity comes out to be this. Yeah, so basically this is it. As mentioned earlier, this is a very comprehensive readme.md file, which basically has everything one might need to go through this project. Every dependency used is here in requirements.txt. All that is used is over here. Also, to convert CPP to JSON, I have used external library, or maybe a header file you must say, by NLman, which basically converts the standard output to JSON. So this was basically it. All instructions, including the exact Docker commands and this testing UI, are available in the repositories README, as I told you. Thank you for your time, and I look forward to your feedback.